Hello everybody, my name is Walter and this is episode 78 of Redstone Commands Series. Now in this series, up to this point, we've covered pretty much all of the commands that are not required for the server administration and also some basic programming concepts. But what we haven't really talked about yet is how all of this can be put together for something a little bit more elaborate. And that is what I want to do in this and also some of the following episodes, just showing you a couple examples for some more practical applications. And today's example will be about dynamically defining a volume to be used in a fill command, which can be quite useful if you only know the position and the size of the to be filled volume during the playing of the game and not beforehand. That is a bit tricky to do unless you would want to just manually type in the coordinates yourself, but it can be done and how I want to show you today. So for that, I have prepared a pseudo data pack here. So this function here would be usually triggered in a data pack via the Minecraft load function tag. And this here would be the Minecraft tick function tag. For this example, I'm just going with some command blocks. And over there we have a cleanup, which is only really useful if you want to remove the data pack. So anyway, we just got two tools. And in the background, we also set a few things in the command storage. So we have some data to work with. But let me show you this action. So we have our tool to mark a corner and we have a tool to fill the volume. So let's start with marking a corner. And you can see it placed an armor stand. That is pure visual. It's not really needed for the function of the data pack, but that way you know where your volume is. And then I do this a second time. And you can see I have now two armor stands. And if I mark a third corner, you can see the first corner disappeared. So I always have only two corners marked, as you can see. And now let's just click the fill command and you can see this was filled with some green glass. And if I click again, it's now yellow, then red, and then it cycles through. So I played around a little bit and I have actually a list it's going through here and cycling the colors. So now let's just add another corner here and maybe a corner here. And now let's fill this again. And you can see I've actually combined or overwritten part of what I already had. And now, just for the fun of it, let's add a third color right there. And yeah, that is the whole thing in action. So now I've turned this off. And yeah, now let's have a look at how all of this here actually works in the background. And for that, let's start with the volume init function, which, as I said, should be usually triggered with the Minecraft load function tag. But in this example, I use the command. Now, this does two things. For one, it prepares the storage content. So we are working with a global data storage called main menu volume. And it also gives the control tools to the nearest player. Our storage content is pretty simple. So we have our first triplet of coordinates, x, y, and z for the first corner, set to 0 all, and then the same for the second corner. Then we have a list which contains the blocks we want to cycle through. So in this case, lime, yellow, and red stained glass. This can be obviously expanded as you want. And then we have an entry called simple block, which is the first entry in the blocks list. This has to be done because functions with macros can't access subcompounds or entries in a list individually. So I have to use this as an intermediate storage. And the volume controls themselves are also relatively simple. They are just carrots on a stick with a custom name, mark corner or fill volume, with some lore you could read if you went into the inventory. And then, additionally, it has some custom data called function. And this is actually the end of a function command. So we have the name of the function with some additional information about where information for the macros comes from. And the same happens for our second tool. Following that, we have our click trigger function, which usually would be part of the Minecraft tick function tag. But in this example, I'm just using a repeating command block to execute it every game tick, so 20 times a second. This does basically just one thing. It checks if I've used one of my tools and then triggers the corresponding functionality. For that, we first create an objective that just increments every time I use a carrot on a stick. Then I'm using an execute command to first check if I've used that, so my score is 1 or higher. Then I'm setting the coordinates to my own position. I'm checking if I'm actually holding a carrot in a stick in my main hand, which is important for a little bit later. And then I'm running my function, which is called click action. We will have a look at that next. But with some additional information, which is actually taken from the custom data of the item I'm holding in my main hand, which was the reason I had to check beforehand. Once I'm done with that, I then just reset my scoreboard objective, stick click to 0, and then I'm done with my click trigger already. Next up, we have our click action function, which is triggered via the click trigger. And this only contains one function call that makes use of a macro. And if you remember back to the previous two functions, this is basically the function that was defined in the custom data of our tools. So either the volume mark corner function or the volume fill cycle function in this example. So a pretty simple way to dynamically define the function you want to call using the NBT data of the item itself. So I don't need to hard code multiple actions. I can just use one command here or one function here and then dynamically drive it with the NBT data. And that brings us to the first main function, the volume mark corner function, which, as the name implies, marks a new corner for our volume fill and is called with the storage content in the background so we can make use of that for our macros. So the first thing it does is getting rid of an old armor stand, and the oldest one is at the second corner. So we are using macros with our execute positioned to get to the second corner, and then we position to the middle of that area, and that is where we run our kill command for the nearest armor stand within 1 meter. Next, we need to copy our first corner into the second corner and then override the first corner with our player coordinates. For that, first, we use the data command to just copy x, y, and z 1 to 2. And then we use execute store result to write the player position into the coordinates of the first corner. You could, in theory, do it like this with the data modifies command and copy it just from one NBT data into the other. But the fill command requires integer for the coordinates. It doesn't accept double values. So that would cause some issues. So here I'm using the execute store to basically transform the double values into integer values. That is a rather important step here. Yeah, and then I'm just summoning in an armor stand, first aligned at the XYZ coordinates, then positioned into the middle of that block, and yeah, then I'm also setting no gravity to true because I don't want this to just fall down again. And that brings us to our second main function, the volume fill cycle function, which for one fills the marked volume with the currently selected block and then cycles the block for the next fill. This again is called with the storage content in the background, so we can make use of that for the next command already, which is just a simple fill command, which, as you can see, is almost entirely made up of those macros here. So fill, then we have our first triplet of coordinates, then the second triplet of coordinates, and then finally the block we want to place. So no real surprise there. And then we are just cycling our blocks list. For that, we first copy the first entry of the list onto the end of the list, or add it to the end. Then we remove the first entry, which means that we have effectively cycled the list by one step. And then we have to copy the first entry again into our block entry, so we can actually make use of it in the next fill command in this line here. And that leaves us with just the volume cleanup function, which, as you can see here, just removes all of the storage content as well as the scoreboard objective used for this example. And with that, we've reached the end of this episode about our first practical example. I hope you enjoyed it. I wish you a nice day, and well, see you.